This video is for ITKM 560 and it's on random forest. So let's get started by loading our libraries. So the new library that you're going to need to install is the library for the random forest. So you can just uncomment this and that will load it. Again, to uncomment, all you need to do is take out the hashtag, comment it back, put in the hashtag. Okay? So we'll load in our data. Click summary of our data. Again, same data we've been using for all the examples. And you will see that, again, occupation needs to be a category. Gender is a character, but it's not a category. It's not a factor, as what R would prefer seeing. And children as well. So let's go ahead and create our data set cheaters, which is based on the data set affairs. We are going to create a variable called cheater, okay? Where, again, it's just a 0-1 variable. And I'm also going to make this as factor. And our random number to split our data, gender as factor, children as factor, occupation as factor. And here, this is where I actually put, again, cheater as factor. But anyway, no need for that because I just put it here. And then I'm going to take out the variable affairs because we don't want to be predicting with that. So I have my data set. Let's do our summary of our data. Again, cheater is a factor. We know it's a factor because it's counting the zeros and the ones. Same thing with gender, 315 females, 286 males. Subjects with children, 171 without, 430 with children. All set. Let's split our data to training to validation. Split on a 70-30 split. Again, this is a judgment call. And here we create our model. I'm saying that cheater is equal to all available variables. Type is a classification because it's a 0-1, yes or no, cheater or not cheater. We're using the training data set, and I'm asking to report on importance. Okay? So let's run this. So interestingly enough, if I do a summary on random forest, on RF, this is the object where I stored my model. What does this give us? It gives us a lot of information, okay? Or somewhat. And it's basically just telling us what information is there. And as you see, here we can find that RF dollar importance will give us the importance. And anyway, lots of information here. But really all we care about is that we have our model. This is what happens with random forest. It's a little bit more of a black box, a lot more. So I'm going to take my validation data set and I create this variable called predicted cheater, where I am predicting using the RF model, that object that I created with the model, and I'm using the validation RF data set. Okay, so let's take a quick look at our validation data set now. And here it has cheater and it has predicted cheater. Now let's do our little summary. So it predicted 148 people not being cheaters and 16 being cheaters. But let's do our confusion matrix. And this is going to say how accurate our model is. So I'm going to write some interpretations as well. Every time I run this, given that it selects randomly variables, the model changes just a little bit. But anyway, here we have cheaters. It was able to capture, non-cheaters. It was able to classify correctly. Of the non-cheaters, the zeros, it was correctly classified 92% of them, and 8% wrong. So let's write this down. Of the non-cheaters, we are able to correctly predict 92%, and 8% were misclassified. Then when I go to the cheaters, or let's just see, of the predicted non-cheaters, we were correct. So predicted This is predicted non-cheaters. We're talking about the columns now. We were correct 70.1% of the time. And of the predicted cheaters, okay, again, we're looking at column statistics. We were correct 37.5% of the time. Okay. Continuing here, in total, the model is correct 70.1 plus this is 73.7. It is correctly here and it's correct here. So this 70.1 plus 3.7 gives me 0.8% of the time. And there we go. There we have our random forest. Sorry, out of all the cheaters, we were able to predict. So these are all the cheaters, 39 of them. We were able to predict 15.4% of them. And this is the same thing here. And I just want to highlight the way you word things. So this is the first line is a pessimistic view. Out of all the cheaters, we were only able to predict 15.4% of them. An optimistic point of view, and again, this is important on how you write things. Out of all the cheaters, we are incredibly able to predict 15.4% of them. It really depends on not so much your mood, but rather, is this something really amazing to do? Anyway, that's really it for Random Forest. I will give one last comment about Random Forest, as I said at the beginning, is that it has been my experience that it has been incredibly more accurate than other algorithms. However, the caveat is that it is incredibly more accurate, but you need a lot of data. This data set is 601 observations. When we split it into 437 and 164, a random split for training and validation. When you're dealing with more data, how much is more? Well, it depends how many variables you're using, but more data means 10,000, 100,000, then your numbers are going to be a lot more stable. Because if I were to run this all over again, meaning creating my random number generation, sorry, let me scroll up here. If I run this whole thing again, meaning that this random number is going to be regenerated, okay, you will see that when I create my training and validation, I have different numbers. And the model also turns out differently. Especially here, we can see that in our model, in our cross-validation here, in our confusion matrix, here we're predicting 94.9% of the time correctly, okay? Versus the previous one did only 92, as I recorded it here. 92 and misclassifying 8, here's misclassifying 5.1. So it's very sensitive to a few more observations, a few less observations. That said, when you're dealing with a lot more data, things are a lot more stable. Anyway, that's it for Random Forest.